Yeah, no, thanks a lot for having me here. And as Chris mentioned, my name is Anubhav. I live in Mansfield, Massachusetts, a couple of hours of drive, but it was really fun coming here. So my wife loves Portsmouth, by the way. She just comes here to shop. Just that's it.
You get that a lot.
I know, right? And I love Portsmouth too. But for the today's purposes, we're going to talk about like building multi-tenant SaaS application, right? So I've been at AWS for about 4 years, 10 months. I'll be 5 in June. And since I joined AWS, I've been mostly helping customers build SaaS-based applications. That's what I do in my day job pretty much. And when customers talk to us, they have been like asking us that, hey, all the advisory is great, but do you have some hands-on code which you can share with us, which we can take, and then we can start taking that as a template blueprint to bootstrap and build our SaaS applications. So what we did, we started building some reference solutions, reference architectures, and one which I'm going to talk about today is like how do you build a SaaS application using serverless services, right? So this is like a reference architecture focused around serverless services, still following all the best practices of how to build a multi-tenant SaaS solution. Now, having said that, like how many of you are actually building SaaS solutions right now or somewhat associated with it?
So, I'm peripherally associated with it.
Yeah. And like how many of you are intrigued by the whole multi-tenancy kind of, yeah, okay. So that's why you're here today probably, right? Just wanted to learn how multi-tenancy works and why it is important and how it works. Okay, cool. Yeah, just to set some expectation, we are going to very much focus on the SaaS-based architecture today. So most of the recommendations will be like how to run a multi-tenant workload, giving SaaS in mind. But I'll be talking about a lot of serverless concepts as well and sharing the link for the reference solution and workshop, which you can go back and do yourself later. Please feel free to ask any questions as you have in between.
Can you go ahead and share your the screen to the Zoom folks as well?
Of course.
I thought that was there. I did pin him.
Yeah, I thought that we shared.
Turned it off.
Okay. Yeah, when we were playing around, yeah.
Yeah. And I apologize that you see me with my phone in my hand. I'm going to be monitoring the Zoom chat as well throughout this. I apologize about that.
How about now? Can you see it?
Yep, perfect.
Perfect.
Awesome, thank you.
Cool. Okay. Well, I mean, I know that not all of us are building SaaS applications, but I still want to talk about like what's so special and different about a multi-tenant SaaS application, right? And given the fact that it's multi-tenancy, what that means is multiple tenants or customers are sharing the same infrastructure. What that basically kind of brings is a lot of complications in your architecture, right? So typically when you build a SaaS app or any application, you think about security, observability, right? So these are some of the things that you always are on top of your mind while architecting any application. In a SaaS multi-tenant context, now we are also talking about multiple tenants in that architecture, right? So the identity management as an example, now when you create your users, you are creating in a more tenant-aware fashion versus just creating a user in the application, right? Similarly, when you are logging or metering anything, you are basically metering in the context of the tenant, right? So you need to, and by the way, let me just take a step back. Do all of you understand what tenant really means in this whole SaaS world? And I can give an example, right? So let's say HashiCorp is selling a SaaS application, right? And they're selling that application to multiple businesses. Like you might have like different customers, right? In that context, what happens is that each customer whom HashiCorp is selling to as a SaaS provider is a tenant, or what we also call as end customer, basically. So let's say you sign up for Zoom. We are kind of doing this on Zoom, right? So let's say we have a Zoom instance, and Zoom have multiple customers, right? So each customer is a tenant. Now the concerns that all your end customers usually have when accessing a SaaS application is like, is my data secure, right? Am I going to have similar performance in the architecture as other tenants, right? So that's where this whole complication comes into picture, right? So you might have heard about this term noisy neighbor, which basically means that, hey, if I'm accessing a SaaS application, and if other customers are also sharing the same architecture, how are you going to make sure that we are not impacted if some other customer is running a buggy script and can just bring down the architecture, right? So typically SaaS providers deal with these challenges a lot. I mean, it's a very complex architecture. Sometimes you can get into, you have to like build measures to make sure that when you're building an infrastructure, you are kind of protecting that infrastructure across those tenants, right? And that's where the complication kind of comes into, basically.
I think I've seen it a lot with like PCI compliance, and so if you're a company and you have to follow PCI compliance or HIPAA or things like that, part of your qualification for evaluating vendors may be determined by, is this a shared tenant or am I isolated for some of those security and data concerns as well. But I've seen it be a deal breaker in large enterprise transactions because they were shared tenants.
Yeah, absolutely. So typically when you're building a SaaS solution, you have to figure out what personas you're going to target, right? Are you going to target those small companies who don't care about all those concerns, but price is what's relevant for them, right? So they want something which is pretty cheap. And then you have enterprise customers, like if you're selling to like a big bank, as an example, they'll be asking all sorts of questions. And then the SaaS providers will, so I think the only option you have is get all those certifications like ISO and SOC 2 and just have a proof that how you're handling their data to begin with, right? And that's where all of this become really important, right? I mean, how are you handling tenant isolation? How are you handling noisy neighbor? Do you have enough visibility into each and every tenant, like how they're using the system? Do you understand the cost footprint of running a tenant into your shared infrastructure, right? Because let's say you're sharing Lambda functions across multiple tenants, you can't really tag them, right, using cost allocation tags. So there are other ways you have to figure out. So that's what I'm going to talk about today, like giving some examples, like how we have done that in this serverless architecture, basically. Make sense? So first of all, we think that serverless is very well suited for SaaS workloads, right? The main reason is like when you're building a SaaS application, what you really want to do is focus on your IP, right? What you're selling to your customers. And with serverless, a lot of that heavy lifting of managing infrastructure, figuring out like what resources you want to provision kind of goes away, right? So if you look at this graph, when you're building a SaaS application, you really don't know how many customers you will get, right? So if let's say you start provisioning an EKS cluster as an example, right? So you really don't know how many, or you are basically over provisioning in some cases because you think that, okay, you know what, I'll probably get 100 customers next 1 month. Let me just create a EKS cluster with like 5 nodes and whatever. But with the serverless, you can just scale as you go, right? So for a SaaS-based, unpredictable kind of workload, we think serverless is a very well-suited option. And it gives you the best capacity cost to capacity utilization ratio, basically. All right, so I'm going to talk about like now the architecture that we have built. Before I jump into that, there are 2 deployment models, and as you were pointing towards, Chris, as well, right? So typically there are 2 ways a SaaS application can be built. The one on the left side is what we call dedicated resources for each tenant. Think about like you have a multi-tenant workload. Multiple tenants could be your customers or even internal departments as an example, right? So what you can do is you can spin up a separate AWS account for each of those tenants as an example, or a separate VPC per tenant as an example, right? Now, with that, obviously, when you have hundreds of customers, it brings a lot of complications in terms of you have to manage those hundreds of accounts, hundreds of VPCs, right? So that brings its own challenges. Obviously, it also gets you the benefit of tenant isolation boundaries pretty well defined by account and VPCs. On the other hand, on the right side, where you are sharing resources for all these tenants, basically what that means is you have a set of EKS cluster as an example, set of Lambda functions, right? Now you're sharing those across multiple tenants. And that basically means more cost efficient, brings you more operational efficiency, but then it brings more challenges, as I was mentioning about, like how do you do tenant isolation, how do you implement that observability, and so on. So now coming back to the SaaS application architecture, so what are the services we used basically in this architecture, right? And some of these might be familiar with you. Like how many of you are familiar with serverless here? Okay. So basically API gateway is And by the way, I'm not going to talk about the basics of serverless today. So this is more like around 300 level talk, more focused around like how to use these services in a kind of advanced use case. But I'll touch base on in brief about what these services are, at a high level. So API Gateway is basically a service which you can leverage to build your APIs, right? So we are leveraging API Gateway to build our REST APIs. Lambda authorizers are basically used to authenticate, right, in a SaaS-based workload. Usage plans and API keys are another feature of API Gateway, which basically let you control the noisy neighbor, right? So what you can do is you can associate an API key with a tenant, and you can control the usage. And I'll talk about it in more detail as well as I go, right? Cognito is being used for authentication. Lambda we are using for compute, basically. The storage is DynamoDB. We are using AWS SAM, which is basically another service for infrastructure as a code. Serverless application model, basically, that's the full form of SAM. So what you do is you use SAM to build your infrastructure, your Lambda functions, and all those AWS services using CloudFormation. Then we have CDK, which is also infrastructure as code. Now the difference being that in this architecture, what we did was we used both. We use SAM for serverless deployment, and we use CDK for deploying our deployment pipelines, right? You can obviously use CDK to do both, but the SAM choice was mainly, the main intention was to show that they can both work hand in hand in your architecture if you want to. And code pipeline is basically an AWS service to orchestrate the deployment, right? So I'm going to talk about a little bit more detail how that works. Any questions so far? No?
I guess I'll go on that last slide, just thinking about kind of the timelines of these services on AWS. And I know CDK is not necessarily a service. CDK is kind of the newest thing on here. Have there been any updates in like the API Gateway or Lambda space in the last couple of years that have made it easier or I guess I'll use the word easier to handle the multi-tenant environments? Because I know usage plans, API keys, those have been there for a while,
Yep.
right? And so has there been anything new introduced to help support this, or did AWS get it right the first time and, it's been pretty...
I mean, there have been few changes, updates made, but not specific to SaaS, I would say,
Okay.
right? So there has been many features which has helped for SaaS providers too, right? But if you say that, okay, any native multi-tenancy support in Lambda, that has not been the case recently.
Okay.
Yeah. So in terms of the architecture, right? So what we did was we built 3 different web applications, and they were built using AngularJS. And as I said, I'll share the reference repository with you later as well, which you can dig into. But the idea was, like, if you're building a SaaS application, what do you need? You need a way for your customers to come and sign up, right? So that's the sign up application right there. You need an administrative console to manage all those tenants, right? And then you need that SaaS application, which is your IP, which you're selling to your customers, right? So that was the idea, to showcase like how a typical SaaS provider can start their journey, right? So if you're building a startup, let's just think from that perspective, and you're trying to build a SaaS application, this is how you'll start thinking about, what, I need something to onboard my customers in a self-service way, right? I need something for my internal teams to manage those customers, right? I need something for my customers to log in and access and offer as a service, right? So that was the idea behind these applications. The web application itself was hosted using S3 and CloudFront, like pretty basic, pretty standard approach, like how you would create those static files and and serve through S3. And then coming to the API layer, this is where, as I mentioned, we are using API Gateway as the choice of building the APIs, right? And Lambda Authorizer is used to authenticate any incoming request. And I'll talk about in more detail how the authentication works. And not sure how many have you heard about the STS service? You have heard about, okay. AWS STS service is basically a way to create short-term credentials, right? So typically when you access any AWS service, you have an access key, secret key, session ID, right? But in case of a multi-tenant workload, you just can't have one access key, secret key to access your resources, because you need the tenant isolation boundary, and you need like those short-term credentials so that a tenant can only access their own data. So I'll talk about that in more detail, how that works, but the whole point of STS was to create those short-term tenant scope credentials, right? So that you can pretty much enforce the tenant isolation as you go through. And I'll talk about the API keys and usage plan and how they work, but basically they are a way for you to limit as to how many requests a particular customer can make in a certain amount of time, right? It's basically a way to enforce throttling, basically.
Also sometimes used for billing purposes, right? If you charge your customers per request made and things like that, there's an ability to
So what we did in this case, we associated like a usage plan with a tier. And I'll talk about the tiering concept a little bit as well. But yeah, I mean, so what we have seen is many times you sell that as a pricing model as well, right? Okay, I have an API-based interface. You're allowed to make 100 requests per day. So I'll implement that, usage plan, that tiering mechanism using usage plans now. You're right. Yep. Now this is getting into the weeds of how your application is being designed now, right? So what we have in this architecture is we have two microservices just for example purposes, right? An order and product. So we used Lambda functions as a compute layer. We use DynamoDB to host the data. But the way we deploy this architecture is kind of unique, right? So what you see on the left, what I call pooled, what that basically means when you're onboarding a new customer, you just, all those customers which are like basic tier, share that pool environment. And the idea is that, hey, if you have those small customers and you really can't afford to create hundreds of those environments, we just onboard all of those small customers in that pool environment. But then you'll have some enterprise customers like a big bank who's like, you know what, I'm only going to buy your SaaS solution when you give me a dedicated space, right? And that's where you have those tenant 1, tenant 2, which are basically dedicated resources, separate set of API gateway, a separate set of Lambda functions, DynamoDB tables per tenant, right? But the one important thing to note in this architecture is like a single build is applied across all these different installations, right? So even though you are having separate infrastructure per tenant, per customer, you still in a SaaS-based environment want to make sure that you have that consistent build applied across multiple environments. We are using Lambda layers for logging and authentication. Are you familiar with what Lambda layers is? It's basically a way for you to distribute reusable code across Lambda functions, right? So let's say you have a authentication module, a logging module, and you want all the Lambda functions to share that same code. What you can do, you can basically bundle up that as either an NPM package, but also as a Lambda layer, right? And you can basically now have the same Lambda layer X being distributed or shared across all these Lambda functions. So now you really don't have to duplicate that code everywhere, right? And you can version them separately. So you can deploy a Lambda layer separately. So let's say you have an authentication model. And what we did in this case was we are hiding those multi-tenancy constructs within that Lambda layer, right? So it's just a way for you to encapsulate some of those complications in the architecture.
On this slide, are we scoped to one AWS account?
You don't have to be. In this reference architecture, it was a little complicated for us to show like how things work in multiple accounts. So in this case, what we did, we just use a simple single account, but all those tenant 1, tenant 2 could be in separate accounts if you want to.
Because I think with this and even with the pool, like you still run into services like Lambda and Dynamo have their own, some soft and hard limits imposed the AWS management layer. And so even having dedicated stacks, you're still eating against the same quotas for these services, right?
Yeah, the account limits are applied at the service level, as you said, right? So at sometimes when you reach that maximum throttling for Lambda function, then the only option is to go across multiple accounts, right? And this architecture will support that, right? So it's up to you, like how much load you anticipate, and you think that can you just survive in a single account, or you really need a multi-account strategy. In that case, you can deploy those additional tenants in separate account. So the shared services, which is basically like how you control all of this, they are not multi-tenant, right? So the way, if you think from a multi-tenant, multi-account perspective, you'll have those shared services sitting in a control plane account. You'll have a pooled account. You'll have a tenant 1 account, tenant 2 account, right? That's how you will see. And basically, your deployment pipeline, which is the next and the last component of this architecture, will be sitting in its own AWS account, right? So what you will do, you'll just control the deployment from its own account, right? So that's how you will distribute in a multi-account architecture. So again, as I mentioned, I'm going to talk about very much in the SaaS context, right? So the next thing which I'm going to talk about is how do you register new tenants into a system, right? So the way we kind of handle the tenant registration in this architecture was, as I mentioned, we built those landing and sign-up applications, which were built using AngularJS, right? What we did, we built a registration microservice, which was using API gateway Lambda function, and the role of this microservice was to kick off the provisioning, right? So these web applications will use API gateway, will basically access API gateway and initiate that flow. And then the goal of this registration process is to set up that new customer or tenant into the system, right? So what that means is creating a new user pool if needed for a premium tenant, or just create a new user pool group within Cognito, right? So Cognito is basically a service that we use to authenticate and manage your users. And within Cognito, there is a concept of user groups. And what that means is you can group certain kind of users within those user groups, right? And the idea would be to create the user groups for individual tenants, right? So because keep in mind that when you're creating those tenants, those tenants will have multiple users too, right? So let's say you're selling your SaaS application to a bank. They will have hundreds of users within that bank itself, right? So you want a mechanism to group those users with your SaaS application. So Cognito will allow you to do that. Tenant management is just basically a CRUD operation, a DynamoDB table to store your tenants, right? And provisioning is basically meant for your premium tier tenants, right? So what that means is when you're creating a new premium tenant or platinum tenant, you're going to provision a separate set of AWS resources, and that's where you will have that provisioning mechanism in place. So I'm going to talk about this deployment pipeline for a second, right? So if you recall, the complication that we have in this architecture is you have a SaaS application deployed across multiple infrastructure environments, right? So you might think what that means is just taking one single build. So typically in a SDLC lifecycle, what happens is when somebody commits the code, it goes into a source repository, right? There's going to be like something triggering which will build that source code and produce a package which you will deploy to your infrastructure, right? So as an example, if you're using CloudFormation as your infrastructure as code, you'll commit the code, you'll do a CloudFormation kind of. In case of SAM, what you will do is basically you will build a package using SAM build and SAM package. And the package now has to be deployed across multiple infrastructure, right? So what we did was we used step functions which is an AWS service to orchestrate your complicated workflows. And we built a state machine to orchestrate this workflow. The step function in itself is pretty complicated. I won't go into the details. You can look into the example. But at a high level, what the step function is doing is it's iterating through a list of records, right? So as you provision new customers, you're basically creating an entry into the DynamoDB table now, right? So it's basically keeping a track of how many customers I have. And what the step function is trying to do is it's trying to loop through that and trying to deploy that same build across all these multiple stacks. And that's how it's trying to keep all these stacks consistent with a single build. So you can take this concept across any multi-tenant system now, right? So let's say you have different departments or different microservices as well, which you want to be like consistent. You can leverage this concept of integrating step function into a code pipeline as a deploy step, and use a metadata table to drive that deployment process if you want to, right? One more thing is the wave number. So in some cases, and this is again very much specific to SaaS architectures, right? So let's say you are selling your service to a pool tenant or a basic tenant, like free tenant kind of thing. Like you might have signed up for free tier many times, right? When you kind of sign up for an application. And when you become a paid customer, like you are basically a paid member, right, at that point. So sometimes what these SaaS providers do, they want to experiment a new feature, right? So what they want to do is, what they typically do is that they deploy that feature to your free tier or basic tier tenants, and don't even roll out that feature to some of your premier big customers, right? So that's where that wave number concept comes into play. Like, hey, I want to deploy this feature for all the customers which are in wave number 1, and my step function will wait at that point. And step function has the capability to wait for up to 365 days, right? So if you really want to hold on and test your feature and how it's working for your other customers, you can just wait in the step function for up to 365 days, and then you approve. And basically what step function does, it basically gets a call back that, okay, you know what, somebody approved the next action, and it starts executing and rolling out the same release to other tenants, right? So that whole workflow was actually orchestrated within that step function itself, like how it works. So now you're talking about the by the way, authentication and authorization is not just unique to SaaS applications, right? You need to like build security and a way to like log in for any application pretty much, right? Unless you are building an internal application where you might be just using AD to authenticate users. If you're building an external application, that has to be secure, right? So the way it works is, if somebody is trying to access your application, the first thing you do is you present them a login page, right? That's how we are typically used to operate, right? We see a username password, and we enter the username password. And internally what happens is, and what's happening in this application is, your identity provider, which is Cognito in this case, will send you back a JWT or JWT token, which you might be familiar what JWT tokens are, right? I mean, they are pretty much a standard in how the authentication process works. So a JWT token is basically a token which says, okay, you know what, I'm valid till next 2 hours. If somebody has this token, I can use that to access your application for next 2 hours, right? And what this JWT token has inside it is what we call as custom attributes, right? So what those custom attributes are, basically, they are a way to tell certain internals of that JWT token, right? So as an example in this case, you can say, okay, you know what, this JWT token belongs to tenant ID ABC. The user role is admin. Now you can use these internal attributes which are inside the JWT token in your application to do certain things. Now keep in mind, when you were creating those users as part of the registration process, which I showed you like a couple of slides back, right? So if you might remember, like we had a registration process where we were creating those users. So when you create those users, that is when you kind of store these custom attributes in that Cognito user pool. And when you authenticate, you basically get your tenant ID and user role as part of the JWT token, right? So they are basically part of the Cognito user pool itself. Now, in API Gateway, when you use API Gateway, there is a way how you can authenticate an incoming request, right? The way we do it is, we create a Lambda function and associate that with any incoming API request, right? So anything that is being called to your API that call will be authenticated using this authorizer. And the job of this authorizer is to basically, kind of look at, hey, what is the validity of my JWT token, right? So it will do few things. It will check, okay, you know what, is my JWT token still valid or not? What tenant JWT token belongs to, right? Does the tenant have access to certain resources or not, right? So all of that logic is built inside this Lambda authorizer itself. And then it will do few more things, right? So based upon the user role, it will check, okay, you know what? Does this user have access to do a post or just get, right? So you can build all these measures inside your authentication and authorization process itself. Like, do I have access to create a new record, or do I have access to just update a record, right? So basically the way it works is like, can I do a put versus post or do a get, right? So these things you can manipulate within your authorization policy itself. And I'll talk about the API keys in more detail, but that's also part of this authorizer itself.
When does the API key get evaluated? Does it get evaluated at the API gateway layer or at the authorizer layer?
So basically the authorizer, what it does, it will output as part of the authorization policy the API key itself, right? So that's when it gets evaluated. So an authorizer will.
So if that lambda is invoked, how have you alleviated the bottleneck of a noisy neighbor is there a unique authorizer per tenant because of the
No, it's not. So I'll talk about it in more detail. Okay. Basically, what we do is that we get the API key from the tenant management table inside the authorizer itself. And I have a whole slide on that. But basically, tenant ID will go to the DynamoDB, you get the API key, and then you fetch the API key, and then you pass that API key as part of your authorization output.
Okay, I'll hold until we get.
Yeah,
to that.
and I can show you the code as well if you have time, obviously. So once this whole authentication mechanism is satisfied, only then, and to your point, like only then you hit the Lambda function, right? So it will make sure that the JOT token is valid. It will make sure that the usage plans are all under control. Like, I'm not just creating thousands of requests, right? Once it has done all of that inside your Lambda authorizer, that is when you start hitting the Lambda function, right? So that's how the authorizer kind of plays a very pivotal role in this architecture. And basically, I would say it's kind of the bread and butter of this architecture in many ways. Tenant isolation. So I mean, I know I'm kind of going a little deep and deep, so kind of please stop me if you have any questions. I mean, obviously, as I mentioned, like this is more like a 300 level session, which I'm trying to do here. But if you have any questions on how certain things work, which you're not familiar with, you can please feel free to stop anytime, right? So tenant isolation is typically defined as, if I have multiple tenants in my system, how do I make sure that one tenant is not impacting the other tenant, right? How do I make sure that one tenant is not trying to access other tenants' data, right? So typically, in a silo model, which I mentioned before, which was basically a model where you have dedicated deployments per tenant, right? So in that kind of model, what Lambda function, so when you create a Lambda function, you give that Lambda function a role, right? And if you're familiar with how IAM works, right? IAM is basically identity access management, is a way for you to tell that what permissions that AWS service have, right? So in this context, you can say that, okay, you know what, I have this Lambda function which is dedicated for a customer. So I'm going to create an IAM policy and attach to this Lambda function itself. And in this case, in this example specifically, I'm saying that, okay, you know what, this Lambda function can only access a certain DynamoDB table, right? So if you have dedicated resources for each of your customers or each of your tenants, what that basically means, you can just use IAM constructs to do your tenant isolation, right? You don't really have to worry about anything else. So you just create a policy attached to that service. You basically have a way to access control at that higher construct level using IAM policy itself. But now imagine that if you are sharing that Lambda function across multiple tenants, right? Creating a role or creating a policy at the Lambda function level will not work, right? And that's where you need to start thinking about some of those fine-grained access controls, and that's where those STS surveys kind of comes into play, right? Does this make sense at a high level? Yeah? Okay. So in order to like talk about what pool model is, right? I've been talking about this pool model for like last 25 minutes, I guess, and and you are wondering like, okay, you know what's the definition of this pool model, right? So if I have to like give you an example, this is how it will look like, right? So, and this is again in a context of tenant, which I have mentioned before. Tenant is a business entity which can have multiple users, right? Now, let's say you have a single DynamoDB table which you want to share across multiple tenants, right? Typically, what you will do is that you will have some sort of tenant ID column, which will say, you know what, these records belong to tenant 1, these records belong to tenant 2, and so on and so forth, right? So the one challenge that you might face when you do that in a DynamoDB table is, if you have a tenant which have thousands and millions of records, you might get into a problem, what we call it as hotkey, right? The reason that hotkey problem happens is that internally, when you store those records, all those records with the same shard ID or partition key are stored in a single physical device internally in your infrastructure, basically, right? So one way to avoid is that you can add a random suffix at the end, right? So as an example, in this case, we have tenant 1, and I'm just saying tenant 1.1, tenant 1-4, right? So it's basically I'm just randomizing and putting like a suffix at the end, and kind of distributing the load across multiple partitions, right? So that it doesn't get saturated, basically, using hotkeys. And this is how a typical table will look like in a multi-tenant architecture, right? You'll have multiple tenants sharing the same table, but there has to be a way, right, to kind of to tell that, okay, you know what, which tenant has which rows, basically.
And you would add additional suffix key, you would add additional ones based upon the number of queries so that you would avoid performance bleed over issues where one tenant is washing out everybody else?
Yeah, so basically in this architecture, what we did, we had randomization between 1 and 20, right? So I just took the lower limit as 1 and the upper limit as 20. And I was like, okay, you know what, let me just randomize between 1 and 20, right?
Regardless of how big or how small?
Yes, regardless of how big and small. But you can customize that as a configuration too, right? If you think that, you know, there is a tenant which is going to be like crazy high, you can have that
Give them
a lot more room to wiggle around, right?
Gotcha.
And you can have the randomization script to take the random number anywhere between 1 and 100 as an example, right? The tenant ID, tenant 1 is constant, right? I mean, that's your tenant ID.
Right.
What will change is that random suffix, which can be picked randomly from, or it can just be GUID too. The reason I did not take a GUID is, let's say you have a scenario where you want to get all the records for a tenant, right? And DynamoDB doesn't really have a way for you to, I mean, there's no way for you to figure out, okay, you know what are all my records for a tenant? The only way you can do is, you can loop through all those random suffixes depending upon your range, and you can get all those records which belong to the tenant and as part of those random suffixes as well, right? So that's how you need some way to kind of figure out that, hey, you know, how can I get records for all my tenants? But then it all depends on your access pattern, right? Like, what are your access patterns? How are you retrieving data, right? So that's more of a business decision at the end.
Cool. What factors help you decide if you should have a single Dynamo with multiple tenants in it or a Dynamo per tenant?
Yeah, and that's where the pool and silo thing goes hand in hand, right? So it's basically, I would say, you know, how much limit you have to play around in an AWS account, right? So there are some X number of tables you can create in an AWS account, right? So let's say you have thousands of tenants. You can't even afford to have one table, one DynamoDB table per tenant in that case, right? Because otherwise you'll be ending up just exhausting your account limit like in a week, basically, right? So that's where you start thinking about, hey, if I need to get that optimization, and if I really need to be optimized and be operationally efficient, the best way for me is to create a single table with this kind of structure. I think the upper limit is 3,000 or something. I don't know, you can check the docs, what's the latest upper limit or how many tables you can create. in a DynamoDB. I can't recall exactly, but I mean, if you just check the docs,
Yep.
there is an X amount of tables, maximum tables you can create in a single account, right? So that's where I mean, most of the SaaS providers will be start to think, hey, you know what? How many customers do I have? Like, am I just selling my SaaS software to like some 20 odd customers, or am I just scaling across thousands of customers, right? And that's what kind of drives those decisions.
Is there any way to like abstract this all away from the app layer so that it doesn't need to know about
Yeah.
what strategy you're using behind the scenes as well? Because
Yeah.
like this, it looks like you've got a whole bunch of tenants in one table. So I'm assuming there's ways to
Yeah.
do it so that the app layer doesn't have to care.
Yeah, so what typically you would do is, and we did it in two ways in this architecture, right? So first, we abstracted a lot of details in those Lambda layers, as I mentioned before, right? So Lambda layers was a way to abstract a lot of those details and reuse them across all those functions. And then you create your data access layers, right? Which can also encapsulate all of these things. So typically when you write your code, you have a file, you have a folder which says compute, just as an example, right? And then you have a folder which says data access, right? When you create your Lambda functions, you can just do like a dot and put a relative path and just include that file, right, in your application code, right? So basically, if you have a, let's say, JavaScript file or a TypeScript file, which is handling all your business layer, you can just include your data access layer file into that application layer file using like simple relative file path, and your Lambda layer will pick it up, right? You don't have to it doesn't have to be in a single file, all of this. They can all be distributed modular in their own files. Once you do all this relative path thing and you kind of combine that, when you build using SAM or CDK build or CDK deploy, when it synthesizes that cloud formation, it knows that, okay, I need to take all these files together and put them in a single bundle, basically. And so you can always distribute and create separate files for all this complex logic. Typically just a modular approach, right? That's what we have been kind of used to since writing code, right? Last 20 years, that's what I've been trying to do, right? Just trying to be modular as much as possible. I have seen people also creating NPM packages for those who are kind of used to dealing with Node and NPM, and just creating NPM packages and just giving those to your developers, and they just use those NPM packages as well, right? Those are internal ones. CDK let you create CDK constructs as well. So you can create CDK constructs, again, distribute them using NPM and have your development team. So typically, when you are at an enterprise level, what you do is that you have teams which kind of handle your code and teams which kind of handle your infrastructure, right? Or kind of security teams, right? So what we see sometimes is that some of those teams, they just build their own reusable stuff and then they let the developers use all of that, right? So that's how some of the patterns which I have seen. Yep.
But you still only have one deployed, in your case, 3 deployed client applications. Like everyone's accessing the same S3 bucket hosting your static site.
Yes.
Right. And so from there, they log in, and because their tenant is associated with their JWT, once your service lambdas are invoked, we know the tenant ID, and we can add that as a prefix to fetch our data calls.
Yeah.
And you don't really have to. I think that the application that's deployed, as long as it's getting valid JWTs and that JWT has the tenant information, your business logic is doing all the orchestration.
Yeah, exactly.
What data am I allowed to fetch?
I think the question was that how do you kind of modularize that whole logic of getting tenant ID, appending, and all that stuff, right?
Yeah.
I assume that was your question, that you don't want each and every developer to have that, okay, you know what, I need to get tenant ID from the job token, I need to append in this way, right? So how do you kind of modularize that code? And what I've seen is that Lambda layers, or just creating a separate data access layer to do that, and just having all the developers use the data access layer or NPM packages as a distributable way to kind of deliver those software constructs are some of the patterns which I have seen, basically. So basically, you create libraries at the end of the day, right? Which basically take the job token. And I can show you some code on how we have done that for Lambda layers. So what we are doing is we are taking that we're taking that context from Lambda function, and what those layers do, they basically take out the tenant ID, and they make sure that each and every call in CloudWatch is in tenant context, right? So the Lambda layer is enforcing that within the layer itself, right? So it's kind of a mindset thing, right? Like how do you, depend upon a use case to some time.
In chat, someone informed us that the limit for DynamoDB cannot be increased above 10,000 tables per account.
That might be true. Again, as I said, I don't know the exact details, and these limits keep changing on top of my head. So typically, what we recommend is you work with your account teams, AWS account teams. So each and every AWS customer have their account teams, and you reach out to the service teams to request those limits. But yeah, I mean that's a valid reason for you to not just keep blowing away and creating like one DynamoDB table per customer, right? You do want to like have these patterns, just not to exhaust those account level limits, right? Cool. Okay. Now this might look overly complicated, so I'll try to simplify. And as I mentioned, and maybe keep this diagram in mind for a second, right? Keep this diagram in mind that you have a single table with data from multiple tenants, right? This will help you understand how that STS service works. So typically what we do is that, when, to your point, when we have the jaw token, when we have tenant ID in the jaw token, we know which tenant is trying to access the system. So that is where we trigger the whole process of creating a short-term credential that is scope for the tenant, right? And the authorizer is the one which is doing in our case. And the reason we chose to do authorizer is because you can have a time to live in the authorizer and have a caching policy, right? Because creating those STS token can be a little expensive. There could be some small millisecond latency. So you don't want to do that at each and every call. So one way to cache these operations is to use an authorizer with a TTL, right? So you can have TTL anywhere between, I don't remember exactly, I think it's up to 5 minutes. I don't remember the lower limit, maybe 30 seconds or something, but at least 5 minutes you can have easily. Actually, you can go more. I double check on the actual TTL limits, but in this case, we were like caching for 5 minutes. So only after 5 minutes, you will start doing that STS call again, right? Otherwise, it will just keep caching those credentials for just 5 minutes. And then you pass those credentials to your Lambda functions, and basically when you create a DynamoDB client, right? So this is something which you might have done if you're writing code. When you're trying to access, let's say, a DynamoDB table, what you do is you create a client for that DynamoDB table, right? Using, let's say, Boto3, which is an SDK which AWS provides, right, for Python specifically. And what you do is that you just say that, okay, Boto3.resource DynamoDB, and then you just start playing around with that client. You say DynamoDB.insert new record, get record, whatever, right, API calls you want to make. The difference in this fine-grained approach is now you're passing those tenant scope credentials when you create that client. And this is similar to if you're used to creating a relational database, sometimes you access using a database credential, right? So this is basically a way for row-level security implementation in DynamoDB, right? And this is kind of piggybacking on what we call it as attribute-based access control, or ABAC. ABAC is a way of saying that, you know what, I am trying to control the access by attributes, right? So I'm getting even granular than policies. Yeah. And within each policies, you have a way to specify, okay, you know what? So in this case, like, if you see that kind of highlighted portion, right? So what I'm saying is, this policy have only access to those records which start with the tenant ID, right? Because I have tenant ID -*, right? And if you remember, like in the previous example, I had a structure which is tenant ID -1, tenant ID -4, etc. So now if I replace that tenant ID with the incoming jaw token, tenant ID, I'm basically implementing row-level security in DynamoDB, right? So this, using STS and ABAC-based support, you're trying to use you're trying to basically use row-level security for DynamoDB, right? And now you can just have multiple tenant records in DynamoDB at the same time, and still, might obviously, if you show that to your auditors, and if you have any company which is inquiring that, how are you enforcing tenant isolation? If you show these to your auditors and document them properly, and make sure your developers are kind of following those guidelines, these become a way for you to enforce tenant isolation even within a single shared infrastructure, right?
I know at least a couple of years ago, not all services supported ABAC. I think Dynamo is actually late to the game even as far as ABAC goes. Has AWS gotten better about that? Like, do we know like 90% of services support ABAC?
So ABAC, I don't have the exact list of services, but I know that many services have been adding ABAC support of late. It was something that was released a couple of years ago. I think S3 and DynamoDB did support it at the same time.
Okay.
Yeah. So yes, before that we used to get dynamic policies. Mm-hmm. So what we used to do that before ABAC came into play, we used to have those policies stored in a configuration management system. So let's say you pull that JSON, and then you put the basically replace that string just a string replace, right? The tenant ID placeholder with tenant ID, and pass that to the STS service. But now, since we have ABAC, we just store this whole policy in your IAM. We don't need a separate configuration management system, and we just kind of tag. Basically, you kind of pass that tag, and that's how you do it. So do a quick time check. I don't know, for how long we have, Chris.
You're fine.
You're fine? Okay.
Yeah.
So this is what I was mentioning about Lambda layers, right? Like, there are ways to encapsulate things using reusable constructs like Lambda layers, as an example. And in this example, like your microservice, which is the product or order, is basically passing that context to a Lambda layer. And Lambda layer is basically making sure that, hey, I'm encapsulating all of that stuff from the developer, right? And I'm making sure that whenever I log something, whenever I meter something, I'm always doing it in a tenant context, right? And they basically just kind of hiding away those complexities from the developers. This is just a way to show like how we are logging with tenant awareness in CloudWatch, how we are generating metrics in CloudWatch. That's on the right side. So left side is just plain logging. Right side is how you create metrics using EMF format. It is basically an optimized way to create metrics in CloudWatch. And then on the bottom side is basically how you trace your request using X-ray, right? So all of that is now happening using tenant context, basically. So this is what we were having the discussion before, like how the API key and the usage plan stuff works, right? So typically, what we do is, like, when you get this jaw token from your tenants making requests, the jaw token has tenant ID, right? So what we do is that if you see at the bottom, we basically knows that which tenant have which API key, right? And based upon that, we basically pass that API key, and it's just the job of authorizer to apply usage plans, right? As long as you just pass that to the authorization policy, the authorizer will ensure that the usage plan is applied, right? So in this example, you can only do 50 requests per second as an example, right? It could be per second, I think per day, per week, right? You can just handle at different levels. You can burst up to 50 requests. You have a quota of 1,000 requests per day as an example, right? So you can implement these quota management and usage at your API level. So if you are building an API first strategy, or if you're building a SaaS application which relies very much on the APIs, you can use this as a way to basically sell your application with different tiers, right? So you can say that, okay, you know what, my certain tier will have this much burst, my expensive tier will have more burst, right? So you can kind of package your SaaS application and API that way. Make sense? Yeah, I guess one last topic I want to talk about, and then we can just maybe see if any questions, right? So one topic that we really get pretty often is, hey, now you're sharing resources across multiple customers, like how do you attribute cost, right? Typically, when you're building an AWS infrastructure, you start by cost allocation tags, right?
You mean that's not the first question?
I guess I would say it's actually a very frequently asked questions, and these days it's being asked more often than before because customers are very, and I guess the reason why customers and SaaS providers, are very much focused on this is because you might have noticed like the usage-based pricing is becoming very popular these days, right? So, hey, you are being charged for how many APIs you have, like how much data volume you store, right? So basically based upon a certain unit, typically SaaS providers are charging their customers, right? So now they need a way to kind of make sure that they are profitable, right? So if they're charging their customer, let's say $500 a month, how much is it costing for them to run that customer in their AWS architecture, right? So that's the kind of problem statement is kind of coming from. And when they are not really creating separate accounts or VPCs or separate infrastructure per customer, like how do you figure that out in a shared environment, right? That's the whole complication aspect that kind of comes into play. Typically the way we approach the conversation with customers, right? We say that, okay, you know what, do you really need that cost, or do you just need to know the consumption, right? Like, do you just want to trying to understand like tenant 1 is 10%, tenant 2 is 20%, or do you really want the penny level detail, right? And the key here is to capture those metrics. So if you remember, like we talked about Lambda layers and different ways to capture those metrics. So the idea is to capture those consumption-based metrics and use them to drive the cost approximation in a shared environment, because obviously cost allocation tags will not work, right, as I mentioned, if you're sharing resources. So if you have a single DynamoDB table across thousands of customers, the cost allocation tag will only work at the DynamoDB table level, right? You won't know within the single table, like, okay, you know what, this customer is using how much percentage of that overall consumption, right? The only way is to figure out by capturing some consumption patterns, right? So how do you capture those consumption patterns? So as I mentioned, like you start by logging and metering everything first, right? If you might have listened to some of the Werner Vogel's keynotes, Werner Vogel is the CTO of Amazon.com. He basically says log everything, right? I'm a firm believer, like you should just log everything if you can in your application. And what you can now do is, if you're logging stuff in CloudWatch, you can run these queries. So the queries you see on the right side are kind of a special syntax of how you query CloudWatch logs using CloudWatch log insights. So it might look familiar. You have that sum clause, you have that filter, which is basically like a where clause in a relational database, right? But the kind of catch here is that you start capturing those metrics. So as an example, in the top right example, we are capturing for each and every call made to the DynamoDB table, what was the RCU and WCU consumed, right? So when you make a get or a whatever call to DynamoDB, you can tell DynamoDB that, you know what, give me back how many RCUs and WCUs were consumed as part of the request, right? And that is how DynamoDB measures and price you, basically, right? And you can just keep capturing those in a tenant-aware fashion, and then you can kind of do a sum at the end of the day. Okay, you know what? This customer used 100 WCUs, 100 RCUs, right? That customer used 500 as an example. And you just keep capturing and aggregating these metrics over a period of time. Now, cost attribution now basically is, okay, you take their usage patterns, and then you take the overall cost of your running AWS. The overall cost is, again, for those who are familiar, how to visualize cost, there is something called as AWS cost and usage report that gets generated every day and stored in an S3 bucket, right? So basically, AWS will give you a visibility into the cost of your infrastructure by producing that S3 that report and putting that report in an S3 table. And now you can start querying that S3 table using Athena, basically, right? And you can run those queries. And now what you can do is that you can basically say, you know what, if a tenant has 50% consumption in my architecture, then yes, the 50% of the overall cost belongs to the tenant, right? It's as simple as that. It's simple math. You basically divide the overall cost into, you're kind of apportioning by consumption basically at the end of the day, right? So in this example, as you can see, I'm taking total invocation as an example. So the total invocation for tenant 1 in this case is 6, and the overall invocations were 12. So I know that this tenant was 50% of my overall capacity just because I was capturing everything in my logs and metering it. So now from the cost and usage report, I knew that the overall service cost for that day was 10, and I had 50% consumption, so I'm going to divide 50%, right? Very simple math. So it's basically a consumption-based approach in a shared environment at the end of the day. Cool, okay, I'm going to skip this slide. It's not really relevant for today, but these are some of the links for all the workshops and reference solutions that we have built, if you really want to play around and dive deep. But yeah, I mean, that's all I wanted to talk about for today.
What does the serverless SaaS workshop run through?
Through Workshop Studio.
Yeah, I mean, what does it introduce to you? Like if you run through the serverless SaaS workshop, what?
The whole architecture I just talked about today is basically explaining. So what we have is 7 labs in that workshop.
Yep.
Each lab talks about the problem statement I talked today, right?
Awesome.
So it's a 4-hour-long workshop. So my 45 minutes talk was basically a condensation of that 4-hour-long workshop. So I just wanted to introduce you to the concepts. If you really want to dig into that, each and every lab of that workshop takes you in very much detail through the code of how things are being built and how, like, whatever I talked today, it basically gives you that hands-on approach, and you can run that in your AWS account if you want to.
Yeah, I want to play with the ABAC tenant isolation one too.
Yep, that is a blog which basically the workshop uses as well. I think workshop should be the start where you probably want to start. But yeah, I mean, ABAC blog has code examples as well.
Cool. Awesome. Thank you very much.
Thank you.